Success. It is working fine on cardboard. I also test it with my watch here. You can see the blipping of the LED is in accordance with the secondary. And this blip is opening exactly when the secondary from my watch is changing. I had to to close it and opening the circuit many times actually to be synchronous with my watch that I'm having here. I had to block it until I catch the same timing pretty much. These two devices are powered separately, so it's a matter of synchronization. And yeah, I roughly synchronize it with my watch pretty much, and it is by the second, and I'm super happy that this circuit finally worked. And separately from that, so it's a clone of that what I'm having here, and it's very cool, very cool. I used a lot of scrapped and burned wires that I'm having, copper wires from Bobbin. So this module that I'm having here, I still have to put a switch there. So this module that I'm having here, it will be in continuation of this device that I'm having here. So it will be here on the top, like that, something like that. And yeah, one problem I have, which I didn't, well, think about it too much, is that, actually, let me show you here. So this is the signal wire, and that is another signal wire, and is interrupting between is switching between the signals, and this module is functioning here with the variable potentiometer, and this circuit is beating by the second, and pretty much I'm switching between the signals, okay, with this switch. But the problem is that they will work all the time, so I'm not really sure which one is actually operating or in function, because they are both blipping when I'm switching. So they are blipping only the signal I switch between them. I should switch the power of the module, to switch the power for this and cut off the power of that. And it's a bit yeah, funny. It's a bit it's a bit funny, and I didn't really stay and think about it. So this is a terrible design error, but I had other bigger problems to resolve, and this will be the next project problem to resolve. Right now what I'm having here is it will be good enough, even if it will blip like an idiot all the time, this one and the other one, and yeah, I know, but it will be practical. They will do the job pretty much. They will do the job, and yeah, it sucks that they will blip continuously, both of them. It sucks. Okay, that's it for this. I'm extremely happy that this module is actually working pretty much from the first try. After I finished building it, I forget this this reset pin from the 4060, the reset pin that is going to ground, and this actually helped me by leaving it here. I looked there on the connection. I had the inspiration to look on the connections, and I see that little orange, you see that link there to the ground, and then I remember the circuit, and here is not, I forget to make it here. I forget to make it here, this connection from here to here. So I got back to my computer and I made the rectification in my 3D software. Of course, this is an image here, and but that was the problem. And it didn't work at all when I first connected everything. And then I looked there. I had the inspiration to look there and to kind of look why that worked. And yeah, I find the problem after all. And it is perfect. It is perfect. Absolutely gorgeously. I really love this LED that is not focusing, is diffuse. It's very diffuse plastic here, and it's excellent, absolutely excellent. I wish this is a scrap LED that I'm using here, and I wish I had more of these diffused plastics. They are viewable from every angle possible. So yes, I'm very satisfied, and also a already burned resistor, which is fine. It's good enough, you know, especially for a LED. Is good. All right. Thank you very much, and see you later on the next part of the project, when I will actually integrate this with the rest. After I will put that switch as well, that switch there, and I will think about a way to cut power from this, at least from this device, because from the other one I don't think so. Yeah, I will have to think about it. All right, thank you very much, and see you later. Bye bye. All right, this is the premiere of the of the circuit. It's a very long one, as you can see. It's quite a long circuit, as long as, I don't know, one and a little bit, one palm, one hand and a little bit. It's very long circuit, but I'm very proud of it. I'm very proud of it, and I'm also laughing like an idiot because it's working, and because it's working absolutely exceptionally. Right now is on variable probably. Let me switch it on. 1 second exactly. So when this LED is on, this is switching. You see this last digit. Don't make an abstraction of everything. Let me reset everything. Okay. So this is the module, the last module that I've added here, and I made it exactly like I'm having it on my 3D sketch. And yeah, forgive or make abstraction of the sound itself. It's shitty as fuck. Make abstraction of the entire counter. So let me reset it to 0. I'll make abstraction of the sound that is hearing, because it's not about the sound. It's very shitty sound. I know. What I concentrated, this last module I've added, this 1 second clock here. Here it is, 1 second clock, and I'm extremely happy about it. I integrated. It is working. Pay attention on this. Make abstraction of this little one. I will keep my finger on it. So when this LED, big LED white, is beating, the display, the digit is changing. Exactly when that is on, this is changing to another, you see? And it's absolutely cool, very, very cool. It's also beating exactly as my watch. Yeah, they are kind of synchronous. So look on my secondary digits and also on the LED that is beeping, that is blinking. And yeah, you see, it's the same. So this 1 second beating is the beat is per second. This circuit is doing the exact same thing as the circuit that I have it in my watch here. Is doing the exact same thing. This is the idea that the quartz, this frequency of the quartz that I'm using here is used in all the clock circuits in the world, pretty much. At least the commercial clocks. I'm not talking about the atomic clocks from the submarines or from NASA or from ICBM, intercontinental ballistic missiles. I'm not talking about those type of clocks, which are extremely precise. This is like a commercial precision. You know, it's good enough, and it is doing the job. Probably there is some delay per month if I'm letting it running all the time. Probably there is some errors, but I didn't test it yet. And for what I need, a couple of seconds to beep and to count something per second is absolutely is more than good. is gold and with a diamond on top of it. That's how I'm perceiving it. You know, it's more than enough and more than good what I'm having here. It's extra good what I'm having here with this crystal, instead of using an RC with a capacitor and a resistor. Yeah, okay. So this is very, very, very good what I'm having here. I didn't expect to be this good, actually. It's the same as it was in the tests that I did before. I'm very, very happy that it's working as it should have been. It's originally I was thinking I can make it with 7414. I was thinking on something very, very simplistic with a capacitor, a resistor, and this Schmiger trigger integrated circuit 7414. It is auto oscillating. One gate from it is auto oscillating. I probably did it here with this LED, that very, very small resistor that is there, and probably this extraordinarily big capacitor. Probably this is the entire circuit, and the LED is going to the ground there, and also this potentiometer as well, and some one single gate. So that's the entire circuit for variable. So that's what I was thinking originally. I was thinking to make something similar with what I'm having here, without the potentiometer, of course, and without this big capacitor, with a very small capacitor. I actually bought a couple of SMD larger values capacitors, and I have them, so I can make it very, very tiny little bit there on one single gate. But people told me that that approach, so it's influenced by temperature, and if it's too hot a day or too cold a day, it will not really beat on at 1 second precisely. So people suggest me, I'm talking with in a forum when I'm discussing, I'm putting to discussion my projects, and I thank to all of them, those guys. Yeah, the people told me not to rely on a capacitor RC oscillation, and rely and trust on crystal oscillation, because crystal oscillations are very stable with temperature, with changes in temperature, like a couple of probably tens of degrees of temperature. I'm not exactly sure how much, but it's like 0 degrees Celsius up to 20 degrees Celsius is staying put. Is not changing visible, or probably I'm not exactly sure, but probably this is the range, or 30, maybe 30, and after that they go out of spec or something. Probably maybe they are on all, but no component is staying the same on extreme temperatures, pretty much. It's, if the temperature is too extreme for the component, I mean, it will go highway, it will go in the woods, pretty much. That's valuable for every component in existence. Doesn't matter if it's a crystal, capacitor, resistor, whatever. It's changing the values with the temperature. So people told me to concentrate on making this crystal circuit, and I did it. And I'm very, 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 absolutely proud of it. One single thing that it missed from my last video, it was this switch, and I made all the connections, and now is actually switching between this circuit, variable circuit that I'm having here, and this fixed 1 second clock circuit that I'm having there. And also I prepared it already. So let me switch to off. So this is on. I know you cannot see it very well, but it was on all the time. So now I'm switching it to off. Now it's beeping this one, which is variable, and I can prove it if I'm changing. It's staying as long as that is staying, and so this module is activated right now. And if I'm changing it, you see, and if this is the maximum. Unfortunately, I changed the capacitor with a larger one when I didn't have this 1 second clock module. So that's so I could theoretically reach 1 second with this circuit, because it's very slow, And I was looking on my watch and kind of synchronizing my watch with the beeps that I'm getting here, and I was getting 1 second from variating like that manually. But it's really, yeah, it's good enough. I mean, if you want to count something by the second, this could be a thing. But then I propose as as an upgrade for this entire project, this module with 1 second clock, which came in the very last. I finished everything, and I probably I was thinking before while I was working on this project inside it, and I was thinking to add this. It was in plan probably, if I remember right. But it came last, absolutely last, the last module in the entire project. I had to glue it underneath and drag the wires and make the connections and everything. So I had to adapt it to this already made. So I have it made in 3D, and then I added this to the 3D. So this is the variable which module that I'm having here. Okay, I will leave it as closed actually, and yeah, you see, it's closed. When I put the potentiometer to its minimum, beating is not doing anything. It's just remaining freezed like that, which is a option. You know, this is like an option. The only problem is that, like I said before, this will beat by itself. I mean the LED, and this actually the entire circuit is beating by itself, and this is beating by itself, and they are running in the same time. You know, and it can be confusing. But I will discuss. I did find a solution for the problem actually. But let me present the other option that I'm having here. So I stopped the clock here, and I'm having this guy which is not connected at all. I disconnected it. This is my variable frequency generator with a 555. Let's see, plus there. Yeah, and this is beating by itself, whatever beating. But I have to switch it from here. So this is the switch for it, and now. I'll make abstraction of this because, like I said, this is a module that is beating by itself with no relevance. So look on the screen here on the second, and it will blip in the same time with that LED that I'm having there. And you can hear, this is 1 kilohertz here, 1000 hertz is the maximum, 1200 kilohertz. Yeah, it's not linear at all, it's very non-linear, like that. And I can bring it to very, very slow. So this is from an external source, and I can measure something, you know, in this with this method. In this method, I can. This is how is it? Yeah, it's a little bit funny, but it's probably because I put this buffer here made from a little bit of paper, and I buffer it down because it was too retardedly loud. It was excessively loud. So that's another option that I'm having here, the external thing. Let me switch it back. Of course, yeah, let me switch it back. Okay, and now it come back to this variable circuit here, and now let me switch it on from here, you see, on 1 second, and it is switching accordingly with 1 second perfectly. Also, the other option, I can let it beat 0 and 1 a little bit, and now I can count it down, and I made what? Why did you switch like that? Huh, interesting. Okay, and now when I'm counting down, beep. Yeah, it's not cool that it changed. I don't know why it's changed. So let's see, if I'm switching this guy, it shouldn't have. Probably I touched something there with my hand. Yeah, no, exactly when I'm changing the that's not cool. That is not cool. Only when I'm changing down it's changing. Probably I will have to be very I have to, yeah, I didn't notice this. It's a tiny little bit of error, but it's having this functionality. You know, I can count up and down. You see, beep, and now up, beep. Okay, but the idea is that it is beeping by the second. And yeah, I said this module, so pretty much this entire project is finished at this point. But I want to add a little bit more functionality to it, like I did with this guy here. And I discovered this thing very late, this output for the oscilloscope board, which I drag it from the integrated circuits, the 4033 that this guy is having inside. And from here, I want to drag the same wires and to make a similar module like I'm having there. So that's probably absolutely the last module that I will add, and I have no idea where to put it, where to add it, where to fit it. Probably here on the bottom. I have no idea where to mount it because the chips are here, exactly in this area here under this cover. And this is the driver with 2 rows of integrated circuits, one line there and the second line here. And the third line of chips is the brain that is actually counting and also transforming the numbers, displaying the numbers. And I'll have to find a way. I have no idea how. But that will be probably absolutely the last module that I will want to add to this entire project. One last thing about this 1 second clock. Oh, it's too big. It's very big. I really wanted it to be as small as something very small from this chip. but it turned out very extremely big. But it's doing the functionality that I want, so doesn't matter the size, probably. For now, for this prototype that I'm building here, for absolutely no reason. It's even if it's big like that, it's good enough, you know. And it's doing the job. That's the thing. Yeah, everything is working. This is the conclusion of this video, and I will leave you with this. I hope you like my invention, my prototype that I'm making here. It's more it was a lesson. It was a package of lessons, and I had to build a lot of modules, very specific modules that are doing specifically one single thing, and I had to combine them together to do what you are seeing right now, to make a device from it. It's a counter device. It's all that is doing is counting, and it's having some functions, and that was the original idea from the very beginning. I said exactly this is what I said it, to make a counter with many functions as I can, and deal with the problems until it will work. And I did it, also with the help of my friends, mainly the English UK friends. I thank everyone that who help me, who stay with me and discuss the problems and solve the problems and find solutions and give me ideas. They not give me the solutions right away, but they give me ideas. Sometimes they give me solutions as well, but most of the time my discussions are for ideas and for troubleshooting most of the problems that I'm having, you know. And they are great, and they like to play. They like strange toys, like I'm building here. Probably they like it, and that's why they were on the wave, on the same line, on the same frequency of thought with me. They help me because they like this kind of stuff that I'm building here, and I like it as well. And yeah, I hope everyone that is looking on my videos can appreciate the modularity and the upgradability, how relatively easy it is to upgrade it and to add more modules to it, because after all, everything here is made on cardboard with wires and the chips and the components that are glued are soldered on pads that are glued pretty much, and majority of the pads are glued. Some are bent pads that are receiving the components on them. So yes, I hope you like it, and leave a like as well on all my videos. If you watch a video, put a like there to count how many people are watching my videos, you know. And yeah, that's it. Probably I will make that. That's the sound of the end. I feel like my buzzer. It's very, very strange. If you leave it in a church in the night, in the middle of the night, doing this sound, it will wake up all the dead. Yeah, yeah, it's very funny. It's very funny. It's a funny project. All right, thank you very much. I hope you like it. I hope you laugh as I laughed, and hopefully in the future I will. Of course, I will have to make a case. I'm mentioning the case for a very long time, and it will have a case because all this cardboard is bendable and flexible, and being this bendable and flexible will tear off the connections, and I'm very careful with it in the stage that it is right now, and I will have to add a long piece of wood underneath it and probably glue it or press fit it somehow on that piece of wood that will offer a very rigid surface, and it will be no problem after that. I will be able to manipulate this entire device, whatever, like any other normal device, pretty much, without thinking too much on it destroying something inside. Yeah, but even if it's crapping something, even if it's damage something inside it, it's extremely hackable, extremely repairable, and that's what I love about it. And everything should be made like this, very, very hackable. All right, thank you very much. I hope you like it. I hope you like this strange, weird project that I'm having, and I'll see you later. Bye bye.